functions, trigonometry function, and hyperbolic function, and some other miscellaneous series. And these are the Taylor series. Now this is a way to get the this series value equal to pi divided by 4, and it starts from this function, and I will show you in the next slide. This start with this function, and suppose this is equal to cosine plus sine, and you go through this, and eventually you will get the function equal to 4 divided by pi multiplied by this expression, and you can get pi over 4. Okay, I will show you another example. Is this one, infinity series 1 divided by r squared, and is equal to pi squared divided by 6. And you expand the polynomial function by polynomial term like this, and you go through all this, and then you're assuming this n equal to infinity, and go through this sine x equal to this, and then you come up with pi squared divided by 6. That's a precaution. Some of the function you cannot do it this way. These are two more examples, two infinity series sum, and you can see if you do it this way, easy way, you can get a 1/2, and this series will be 3 and 4, 3 1/4, by just express it as partial sum and calculate the limit n to infinity. These are another way of doing the pi over 4, and you can use arctangent to do this. Okay, now we look at this infinity series. There are 4. I will list 5 theorems about this infinity series. For example, number 1 will be AR term cannot be converged unless the limit n to infinity of the term an equal to 0, and the condition is necessary but not sufficient for converge. Theorem number 2, if it converge to S, if you multiply by a constant, it will just a constant multiply the limit. Theorem number 3 is 2 sequence converge, and when they add together, you can add together. Theorem number 4 is if it's infinity series converge and you add a constant, you just add a constant. So in this theory, this all can be proved. You can look at it yourself. So you can actually remove or insert finite number of terms. Theorem number 5, subsequence. For example, this sequence converge to the same sequence like this, and this sequence is subsequence of this sequence. Okay, now we are looking at the infinity series consists only in the positive terms, and you can test the infinity series converge or not by doing many tests. And one of the tests, I will list a couple of them, comparison test. So you can see if AR less than BR, if BR is diverged, AR is diverged. And if this is converged, the AR will be converged if AR is less than BR. And if AR is greater than BR, BR diverge, AR diverge. And these are proved. So you actually integrate something like that. And these are example harmonic theory. If you arrange term like this, and each term is greater than half, so this diverge. So this sequences diverge. However, I'll show you in the next slide. You break it this way, it had to be a positive term or absolutely converge. Only in that situation you can arrange your sequence without affecting the sum, the converge. So example 2 is a P series like this, and P equal to 1 is diverged. P less than 1, you will be diverged. P greater than 1, it will become converge for P greater than 1. Okay, like I say, the infinity of only positive term or absolutely converged series you can arrange like this. Another test is a ratio comparison test, and it's listed here. And I will give you an example here. And another test, deliberate ratio test, and it's listed here. And I'll give you an example here. And this is a Cauchy integral test. So if it is a positive decrease term, if it exists monotonic decrease integral function f, then 0 less than partial sum minus the integration less than function of 1. And you can see, so the test shows that if converge when the integration converge, and these are proved. It's all listed here. I give you an example here. And to understand this, to derive with this example, you need to understand improper integration. If the ranges go to infinity, what happened? If integrand go to infinity, what happened? Or if both go to infinity, what happened? This improper integration. I give you all this for your information. And you need to understand exponential function, natural logarithm, and you need to know chain rule. These are the chain rule, and integration by substitution or transformation. In here, I give you these are information for you. And these are example of getting the Euler's constant by using this integration test.